All right, so as you can see that right now switch 1 is having like some of the VLANs. Yeah, VLAN 2 is there. I'm gonna to create some more VLANs over here, like VLAN 1 to 10. Show VLAN brief. Let me show you now. All VLANs available. See, all 10 VLANs are available here on switch 1, and now these VLANs must present on switch 2 and switch 3, switch 4 as well, if they are in same VTP domain. But I think so that VTP is not configured on all these 4 switches. So we have to create now VLAN 1 to 10 on all switches manually. And you know very well switch 1 is not going to form trunking with switch 2 by default, right? So interface range fast Ethernet 1 by 0 by 21 to 22. Switch port mode dynamic desirable. Show interface is trunk. You will come to know that now trunking has been configured in between all switches, right? 21, 22 have also become as a trunk port. Fine. So finally what I want that switch 1 must be configured as a root bridge. Now we have two options: either we can perform load balancing or we can configure the switch 1 as a root bridge for all existing VLANs in this switch network, right? However, you can also do one another thing, like here you are having 10 VLANs. For first 5 VLANs you can configure switch 1 as a root bridge. For next 5 VLANs you can configure switch 2 as a root bridge for the purpose of load balancing. So it is also possible in PVST plus to get load balancing, as you know that by default PVST plus is running on all these switches, right? So it will be better for you to get to configure load balancing here for STP, right? So what can we do? We can configure the switch 1 as a primary root bridge for VLAN 1 to 5, and we can configure primary root bridge switch 2 as a primary root bridge for VLAN 6 to 10. And along with that, what can we do? Like here we are having this topology. Switch 1 is there, switch 2, switch 3 and switch 4, and you know very well that all of them are interconnected with each other, is not it? So now what I want, that switch 1 must be configured as a primary root bridge for VLAN 1 to 5, and switch 2 must be configured as a primary root bridge for VLAN 6 to 10. Fine. And then what can you do? Let's say that in case if I want actually that in case if switch 1 goes down, then switch 2 should be root bridge for all VLANs now, right? So what can you do? You can configure switch 2 as a secondary root bridge for VLAN 1 to 5. And I also want that in case if switch 2 goes down, then switch 1 must be root bridge for VLAN 6 to 10, right? So for VLAN 6 to 10 I can configure the switch 1 as a secondary root bridge. And now you must be knowing that what is the function of keyword this what is the function of primary switch, what is the function of secondary switch, secondary root bridge. Actually you know very well that in case a primary root bridge will go down, then definitely secondary root bridge will be elected as a root bridge, is not it? Now to achieve this task we have two different methods. To achieve this single task we have two different methods. Like either you can modify their bridge priorities manually, statically, or you can also use keyword primary and secondary. Let me use these keywords primary and secondary first, and then I will let you know that why is it necessary to configure their priorities statically, right? So let's start it from switch 1. By default all switches are having default priorities 32768. So as I said, according to diagram, that I wanted to configure the switch 1 as a primary root bridge for VLAN 1 to 5. So for those VLANs we can say spanning tree VLAN 1 to 5 root is what? Primary. So once you will configure this primary keyword for these VLANs, then for all these VLANs this switch will configure its priority as 24576 or 24672, something like that. Let me show you. So once you will configure this primary keyword here for VLAN 1 to 5, so it will configure its bridge priority from 32768 to 24576. Let me show you. Show spanning tree VLAN 1. So now its bridge priority must be 24576. As I said that once you will configure primary keyword, it will change its bridge priority from 32768 to 24576. And then after, if you want to configure this switch as a secondary root bridge for VLAN 6 to 10, so you will say spanning tree VLAN 6 to 10 and then say root secondary. Once you will configure the secondary keyword for all these VLANs, from VLAN 6 to 10, then this switch will configure its bridge priority for VLAN 6 to 10 as 28672. 28672. Let me show you. Show spanning tree VLAN 6. 28672. So remember, when you configure primary keyword, it will configure its bridge priority from 32768 to 24576, and if you say secondary keyword, then it will configure its bridge priority from 32768 to 28672. Fine. Okay, now you know very well that by default all switches will be having default priority as 32768. Fine. So the switch where you configure this primary keyword will be having best priority among all, so it will become root bridge for all those VLANs, right? And in case, let's say, like here I configured secondary keyword for VLAN 1 to 5 on switch 2, right? On switch 2 I configured this secondary keyword for VLAN 6 to, for VLAN 1 to 5. In case if switch 1 goes down, because switch 1 was working as a root bridge for VLAN 1 to 5, right? So in case if switch 1 goes down, then definitely switch 2 will be elected as a new root bridge. You know why? Because switch 2 will be having lowest bridge priority among all, because switch 3 and switch 4 will be having default priority, which is by default 32768, whereas this switch 2 will be having 28672. So of course 28672 is lower than 32768, and lower priority is always preferred over higher bridge priority, is not it? So in this way it will work. But in case, for an example, okay, one more thing, it is not always necessary that whenever you will configure this primary keyword, then it will always set its priority from 32768 to 24576. It is not necessary, it is not mandatory. Let's say that any one of these switch in the network, let's say that you have not configured this primary keyword on any switch at all, right? Now let's assume that one of the switch among all these 4 switches, let's say switch 3 was already having 8192. Let's say its bridge priority was already 8192, and now you went to switch 1 and you configured its you configured the switch as like for VLAN 1 to 5 it is primary, right? So this time it will configure its bridge priority lower than 8192, and this time it will configure it 4096, right? This time it will configure its bridge priority lower than 8192, because, and one more thing, if any one of the switch is already having lower priority, and then after you are going on any other switch and you are configuring this primary keyword, then that switch can configure its bridge priority lower than any other switch, right? Then it can configure. But let's say you have already configured primary keyword, and then after you are moving on any other switch and then you are modifying its bridge priority. Let's say you configured here root primary on switch 1, that's why it configured its bridge priority as 24576, right? And then after you went to switch 3, and then after you configure its bridge priority as 8192, so it will become root bridge now. Switch 3 will become root bridge, and this time this primary keyword is not gonna to do work on switch 1. So if you have configured all switches, you have set their bridge priorities, and then after you are configuring primary keyword on any one of the switches, then after it can change accordingly its bridge priority. But if you have already configured primary keyword on switches, then after if you configure bridge priority on any one of these switches statically, then there will not be any advantage of configuring that primary keyword. Fine. So in this way actually your primary and secondary keywords can work.
So if you do the priority as 0, it doesn't work, right?
Of course no.
Yeah.
Remember that if you have configured priority as 0 on any one of these switches, then definitely it is not gonna to do work. Even if you have configured your bridge priority as 4096, then also it will never work.
Okay.
If you go for 0, if you take the root,
So what? MAC address is there. If both, two or more switches are having same priority, by default they have same priority, which is 32768. So now it doesn't matter whether they are having a common priority as 32768 or 0. Finally, decision will be done based on their MAC addresses. So of course there will not be any problem if more than one switches are having same priority. Is there any problem now? Sure. So I hope that you have came to know that what is the meaning of primary keyword and what is the meaning by secondary keyword. But usually we do not prefer to use these keywords in production networks, because if any one of the switch, let's say that you are going to add one new switch in your network, and it was having lower priority like 8192, then definitely it will become root breeze. So that's the problem by using primary and secondary keywords in your STP. So usually we will always prefer to change their priorities statically, manually. So to achieve this task, let's say that I wanted to configure the switch 1 as a primary root breeze for VLAN 1 to 5. So I will configure its priority as 0, and I wanted to configure the switch 1 as a secondary root breeze for VLAN 6 to 10. So that in this case I'll configure its breeze priority as 4096, and on switch 2 for VLAN 1 to 5 I will configure its breeze priority manually as 4096, and for VLAN 6 to 10 I'll configure its breeze priority manually as 0. So that same task you can achieve by modifying their breeze priority statically, right? You will not require to configure that primary and secondary keyword. And now again you can say that, let's say that okay, on switch 1 you configured your breeze priority as 0 and it became as root breeze, right? And then after, later on you added one older switch in your switched network, switched environment with the priority 0. So again decision will be done based on MAC address, and might be that you added a older switch. Of course older switch will always be having lower MAC address than newer switch, right? So of course your older switch will become root breeze, and again it can change a complete and an entire data flow. It's not it. If your root breeze gets changed in your switched environment, then definitely your entire data flow will get changed. I'm going to prove it actually, and I hope that you can understand it very easily, that if STP topology changes, if your root breeze gets changed, then definitely your entire data flow will get changed, because previously might be that your 19, let's say here it was 21, 22, might be 21 was root port, but in future might be this 23 can become root port. Is not it? So now traffic will start to go through the RP, through that interface which is in forwarding state. So definitely your entire data flow can get changed due to due to making changes in your root breeze. I hope you have understood all these things now. So now how can you prevent your network from such kind of attacks? Like for an example, because any one of the user, for an example, you are having a lot of lane users in your network, might be they can download anything from an internet. Are you getting my point? They can download anything from an internet, and then after, are you getting my point? They can download anything from an internet, and then after they can announce themselves, they can announce their system as a switch, they can start to generate BPDU messages, right? Once they will start to generate BPDU messages, then definitely their PC, their computer can work. Rajinder, what are you doing over there?
So can we change this network?
No, it's not possible. What? Burn-in interfaces MAC address can be changed. Even burn-in address cannot be changed, but you can modify the MAC address, the usable MAC address of the interface. Burn-in address will always remain same. You cannot change that. So I hope that now you have understood all these things. Fine. So let's do it now. As I configured this switch 1 as a primary for VLAN, let me show you, 1 to 5, and secondary for VLAN 6 to 10. Now let's move on switch 2. Let's configure the switch 2 as well. Spanning tree VLAN 1 to 5 root secondary, and then after you can say spanning tree VLAN 6 to 10 root primary, and then after you can see here now show spanning tree VLAN 1, and it's not a root breeze, right? So it must be having a root port. So it is having root port for VLAN 1, right? For VLAN 2 also it must not be a root breeze, and it is having a root port. For VLAN 6, of course it must be a root breeze. So this breeze is the root, and you can see that for this VLAN it have configured its breeze priority as 24576, whereas for VLAN 1 of course its breeze priority will be 28672. And this feature is by default enable system ID extended.
Yeah.
You cannot disable this feature. Do you know? Do you understand what's the meaning by the system ID extended? No. See, let me tell you. Yeah, of course, VLAN ID will always be added into your breeze priority. In your breeze priority, VLAN ID will always be added. You know why? Why is it necessary to add this VLAN ID into your breeze priority? And remember that it is not always necessary to add this VLAN ID into your system priority. it is always not necessary, but it will be depending on the platform, not platform actually, it will be depending on your manufacturer. Like here in Cisco, of course it is mandatory, and on all Cisco devices this system ID extended feature is by default enabled and you cannot disable it. But might be possible that like Juniper or HP or Avaya, I mean those switches will not require to add this VLAN ID into bridge priority. So it will be depending on the manufacturer, on the vendor as well. Here in Cisco it is mandatory, you know why? Because here base MAC address is common for all VLANs. By default base MAC address is common for all VLANs. And in bridge ID, if you talk about the Cisco switches, inside bridge ID, switches will always use their base MAC addresses. And base MAC address will always be common for all VLANs. Now, for all VLANs, by default, your bridge priority is also what? 32768. Now, the thing is, if you are having default bridge priority as 32768, and it is common for all VLANs, and your base MAC address is also common for all VLANs, it means bridge ID will be common for all VLANs now. And here we are running per VLAN spanning tree. So how will it be possible for a switch to separate two different instances from each other? Because if two different instances of STP are having common bridge IDs, of course it is not gonna to be possible for a switch to separate them. It means that you can run only one instance of STP will be there, right? So yeah, in case of CST, it will not be required to add your system ID extended because you will be running only one instance of STP. But here, due to this PVST, you are running instance of STP as per number of VLANs. If you are having 10 VLANs, then of course you will be, your switch will be creating 10 instances of STP. If your switch is having like 50 VLANs, then of course there will be 50 instances of STP. Now the problem is, for an example, if you are having VLAN 1 and you are also having VLAN 2. So if you do not add VLAN IDs inside their priority, then definitely both instances will be having same bridge ID. So of course it will not be possible for a switch to separate them. That is why it is mandatory in case of PVST, in case of Cisco switches, because here MAC address is always going to be same. But actually in some other vendor specific switches, there will be different VLAN for each VLAN. Sorry, there will be different MAC address for each VLAN. And because of, or you can say due to different MAC address for each VLAN, it will not require to enable this system ID extended feature. It will not require to add your VLAN ID into bridge priority. But here in Cisco switches, it is really mandatory. And I hope that now you have understood it, that why is it necessary to add VLAN IDs in system priority, to configure different bridge ID for each VLAN, for each instance of STP. Have you understood it now?
But if Juniper router is attached to the server, any other vendor router is attached to the switch is connected to the Cisco switch,
It will work fine.
and the bridge ID will be shown as without the addition
Most
of
in case of Juniper and Cisco, they are backward compatible in most of the cases. Only few features are there which are not supported by Juniper, and as well as like there will be some features available on Juniper switches but will not be supported by Cisco. They are really few. So I hope you have understood the uses of this system ID extended now, right? Okay, now here we configured primary and secondary keyword. In place of these commands, you could also configure it like in this way: spanning tree VLAN 1 to 5 priority. It says that always increment in the increment of 4096. Why this rule is there? Why is it mandatory? Due to Why is it mandatory? I mean, I'm talking about this increment of 4096. They always says that okay, you can change your bridge priority in the increment of 4096 only. Why?
Two port
What?
Create different instances like we have VLAN 1.
Even with using system ID extended, you can have same bridge ID for different VLANs if you do not follow this rule. If you do not follow this increment rule of 4096, then for multiple VLANs, for multiple instances of STP, bridge ID can be common even after using system ID extended feature as well. You know how? Let's say that there is VLAN 10 and you configured its priority as 10. You changed it manually, you changed its priority manually and you configured its priority as 10. So it will become now. Let's say here you are having another VLAN which is like 15 and you configure its bridge priority as 5. So it will also become. So still you are using here system ID extended feature, but still you can see that for two different VLANs your system priority is what? Common, and MAC address will definitely common because base MAC address cannot be different for different VLANs. I hope you have understood it. Didn't get it? Balaji, what?
Understand.
Sure. So if here I'm also using system ID extended feature, right? Even I am using system ID extended feature, but still you can see that there can be common bridge IDs for two different instances of STP, or you can say for two different VLANs. So it must not happen. And to achieve it, actually here we are using this rule of increment of 4096, that whenever you will change your bridge priority, it must be changed in the increment of 4096 only. Now follow your rule, you will get to know that it will never become same, it will never become common for multiple instances of STP. Any problem? Now because you cannot configure its bridge priority 0, because you can configure it either 0 or 4096. Let's say you have configured here 0 and here of course your priority will be 0 or 4096, and in both cases it's not going to be same. Whether you configure their bridge priority as 0 for both VLANs, or you configure their bridge priorities differently for each VLAN, in any case your bridge priority cannot be same for two different VLANs. So both features, both rules are mandatory for STP, for PVST. In case of Cisco switches, system ID extended as well as this rule of increment of 4096. Understood? Any problem? Alright, so this is that how can we manipulate your root bridge selection by modifying their bridge priorities or by configuring their like these keywords, primary or secondary and all. All right. After it, let's talk about RP election. You know very well that for RP election, first of all, it will compare its cost. Let's do it now. So let me do one thing. No VLAN 1 to 10. First of all, let me remove all these VLANs from all switches. I'll be doing it only for one VLAN. So switch 1 is connected with switch 2 only, and let me do some modification over here. Do show run pipe section spanning tree. Here section command will not work, so you have to say include.
Maybe in this source.
So let's remove all these commands from here.
Sandeep, Harish, Shresha, present. Balaji,
Present.
Pranav,
Yes.
Priya,
Absent.
Balaji, Rajendra Kumar,
Present.
Roshan,
Present.
Ritsu, Ujjwal,
Yes, sir.
Atul,
Present.
Mohammed Abid,
Present.
STPpart, Vishwanath,
Present.
Vivek,
All right. कोई बात नहीं, क्लास के बाद या पहले. So let's say that switch 1 is configured as a root bridge. Once again, spanning tree VLAN 1 and priority 0. So of course, in terms of switch 2, switch 1 would be root bridge, and now it must elect its RP. So of course, its RP is what? 21. Fine. And let me do one thing. Interface range fast Ethernet 1 by 0 by 19 to 20, and then fast Ethernet 1 by 0 by 23 to 24. Shut down all these interfaces, and then you will see that its RP is, let me show you, 21. And by default for all VLANs, its RP will be 21. VLAN 1 to 10. Show spanning tree VLAN 1. Let me show you. For VLAN 1, its RP is 21. For VLAN 2 also its RP is 21. For VLAN 3 is also 21. For VLAN 4 is also. For VLAN 5, for VLAN 6, for VLAN 7, for VLAN 10 also its RP is 21. What does it mean? That by default PVST also works same as CST. Is not it? Hello? Try to understand. By default PVST plus also works same as CST. By default it is not gonna to perform load balancing, because by default for all VLANs a common switch will be root bridge, a common port will be root port. So traffic from all VLANs will always follow a common path. Is not it? So by default PVST plus also do not perform load balancing. So by default we can say that it also performs same as CST. So if we are not getting load balancing, what does it mean? That there is no advantage of configuring PVST plus over CST. So of course we will not configure this PVST plus in this manner. We have to do some modifications so that we can get some load balancing. To get load balancing now, as I said previously, that you can configure multiple root bridges. In terms of root ports also, like here you can see that for right now on switch 2, 21 is root port for all VLANs. What does it mean? That whenever traffic will go from switch 2 to switch 1, from any VLAN it will always go through the 21. It will never use 22, because 22 is not working as RP, and also it is not in forwarding state. Is not it? So by default PVST plus do not perform load balancing, but if you want to achieve load balancing, then you can configure it accordingly, and let's configure it now. Fine. So by default for all VLANs its RP is 21. Now I'm gonna to configure 22 as a root port for all VLANs. Fine. And to achieve that, how can we manipulate RP election? First of all, cost. Very first criteria is total cost to reach root bridge, and here you are having this kind of diagram actually, like you are having one switch, switch 1, you are having another switch, switch 2. So of course switch 1 is working as a root bridge here, so it will be generating zero cost BPDUs, is not it? So it is 21, 22, 21, 22, and by default, because all these interfaces are of 100 Mbps, they are having bandwidth of 100 Mbps, speed is configured as 100 Mbps. Okay, so by default cost is going to be as 19. So whenever switch 2 will compare their cost to reach root bridge via both interfaces, so it will become same. Right now you can see on switch 2 that by default cost to reach root bridge is common for all VLANs on both interfaces. Let me show you. Show spanning tree VLAN 1 interface fast Ethernet 1 by 0 by 21. Sorry, detail. So what does it mean that designated path cost is what? 0. It means that we are receiving zero cost BPDU here. It means that we are receiving zero cost BPDUs here on this interface, and the cost of this interface, cost of our own interface is what? 19. So total cost will be designated path cost plus port path cost. So 19 plus 0 will become 19. Even you can also confirm it on port number 22 as well. So on 22, designated path cost is what? 0. It means it is also receiving zero cost BPDU. And also you can see that it is receiving BPDUs because received BPDUs are 914, is not it? Whereas it has sent only 60, and on this 22 it have sent 48 BPDUs. And if you configure this command once again, because these ports are working as a non-DP, you see it is working as a root port and in forwarding state, whereas it is alternate and in blocking state. So as I said that non-DP will always keep on to receive BPDUs, but they will never transmit any BPDU, is not it? So if you configure this command like for 21 once again and for 22 once again, you will come to know that sent BPDUs will remain same, because they are not sending, they are not transmitting any BPDU out from these interfaces. They are simply receiving BPDUs on these two interfaces. So it have also proved, is not it? So this time you can say you can see here received BPDUs are now 957, and here on 22 it is 944. So of course they are receiving BPDUs on these two interfaces, whether it is in blocking state or it is in forwarding state. What? Yeah, it is port ID, as I said.
Port ID 128 is the priority by default, and 124.
Port number.
I'll let you know right now, just give me 1 minute, right? So here as you can see that cost is what? Common, is not it? 0 plus 19, 0 plus 19. So if cost is common, then definitely it will compare designated bridge ID, is not it? Only designated bridge ID. So here you can see designated bridge ID. This is designated bridge ID and this is what? Root bridge ID. And this time both of them are same. If in the output of this command it shows you that designated root bridge ID and designated bridge ID is common, it means your designated bridge is working as a root bridge. Your upstream bridge is working as a root bridge. In case if you are having this kind of diagram, like after switch 2 you are having a switch 3, in this case you will always find here on this interface that designated bridge ID will be bridge ID of switch 2, whereas root bridge ID will be bridge ID of switch 1. But this time because you are checking this configuration on switch 2, so in perspective of switch 2, designated bridge ID as well as root bridge ID will be common. Have you got it? So now let's move back again on switch 2. You can see that on both interfaces designated bridge has priority 1. On both interfaces designated bridge has priority of 1, and also MAC address is same. It means designated bridge ID on both interfaces is common. And for RP election, if coast is common, designated bridge ID is also common. Finally, what will take place? Designated port ID. Designated port ID. Fine. So this time now it will compare designated port ID. Now port ID is combination of two things. One, port priority plus interface ID. Now it will be depending on platform to platform that what is your interface ID here inside port identifier. If you are working on 3550 series of switches or 3560 series of switches, whatever you are seeing here, like if it is 21 here, then inside port ID, inside port identifier also it will show you here 21. If it is port number 22, then inside port ID also it will show you 22. You can move on 3550 as well, like here on switch 3 show spanning tree. Might be switch 3 is working as a root, yep, and show spanning tree interface fast Ethernet 0 by switch 3 and switch 4. It's like 19 and detail. Let me show you. Oh, yeah, you see port number is what?
21.
And inside port identifier also it is what? 21. But in case of 3750, it will change. I mean, your physical number and logical port number can be different. So don't worry about that. This port number, this logical port number have been allocated by this iOS to this interface now. And this logical port number will be specified here under port identifier. So final tiebreaker, last tiebreaker is what? Designated port ID. And designated port ID is a combination of two different things: designated port priority plus designated port number, or you can say interface ID, is not it? So this time, and one more thing is designated, it's not our own. Like I have also taught you these things before as well. Like if you are having switch 1 here, switch 2, if this is like here 0 by 1, this is 0 by 2, and this is 0 by 2, this is what? 0 by 1. Now by default its cost is common, designated bridge ID is also common. Now for RP election it will be comparing its designated port ID. So it will not compare its own port IDs. It will always compare designated port ID, means it's upstream switches port ID. So this time RP election is performed on switch 2, but it is comparing port ID of switch 1. Because for switch 2, because switch 1 is working as a root bridge, right? So is working as DP. I mean both of them are working as DP. So for RP election on switch 2, it is comparing designated port ID. So by default their priority is what? 128, is not it? So finally interface ID will take place. So 23 or 24, here you can see on 21 it is 23, and on 22 it is what? 24. So which one is lower, 23 or 24?
23.
23. That is why this 23 has been elected as a RP, root port, and this 24 is in blocking state. So I hope that you have understood it now. Have you? For sure. Okay, let's continue it now. I want that 22 must be configured as a new RP. I want to configure 22 as new RP. I don't want to configure this 21 as a RP, right? So as you can see now, you can see show spanning tree VLAN 1. For all VLANs by default its RP is 21. So how can we manipulate it? We have two different things. By using two different methods we can manipulate it. Here in this diagram actually, especially first is cost. We can modify its cost, and then you will see that RP election will be manipulated, or RP election will be reconverged. So I wanted to configure this 22 as a RP, and as you know that switch 2 is receiving zero cost BPDUs, right? So here it's on 21 its cost is what? 19. And on 22 also its cost is what? 19. So on both interfaces total cost is what? 19. Now you do one thing, either configure higher cost on 21 than 22, or configure lower cost on 22 than 21. So you do one thing, go to fast Ethernet 1/0/21. Spanning tree cost can be configured in between 1 to this number. So let's configure it now. 20. 20 is higher than 19, but this time this cost has been changed for all VLANs, because you didn't specify your VLAN ID here. So if you do not specify your VLAN ID before cost, it will change for all VLANs now. So now you can see show spanning tree VLAN 1. Now 22 must be configured as a new root port for all VLANs. And one more thing, if you are going to modify, if you are going to manipulate your RP election based on cost, make sure that you are changing, you are changing your cost at the end of non-DP only. Non-DP, because if you modify cost at the end of DP, it will never have effect on your RP election. Change your cost on that interface who is receiving BPDUs. Do not change cost on that interface which is transmitting BPDUs, because it will always calculate cumulative cost. It will always calculate cumulative cost. So what is the meaning by technical term cumulative here? Cumulative means wherever, whoever will receive BPDU, it will add its own cost. Otherwise, what would have happened? Like whenever switch 1 will send zero cost BPDU out from this interface, because speed of this interface is 100 Mbps. And default cost of this DP is what? 19. So before transmitting BPDU out from this interface, its cost should have configured as, tell me, 19. It should have configured, but it will never, because here STP uses cumulative cost. The concept of cumulative cost. So only and only receiving end will be adding its own cost. So sender end will never add the cost. So remember that if you are going to manipulate your RP election based on cost, so change cost at the end of non-DP only. Have you understood it now completely? Okay, so in this way you can manipulate your RP election by modifying its cost. But this time again there is a problem that for all VLANs 22 have become root port. So let's do one thing, let's move back again on 21 and fine. All right, once again you will see that 21 will become new root for all VLANs. This time what I want actually, that for VLAN 1 to 5 21 should be root port, but for VLAN 6 to 10 22 should be root port, so that we can get some load balancing, right? So interface fast Ethernet 1/0/22, and we can say spanning tree VLAN 6 to 10,
Cost 18.
make it 18, lower than 21.
9.
On 21 it is by default 19. Is not it? So this time we have configured its cost as 18, and on interface 21 its cost is configured as 19. So now let me show you. Show spanning tree VLAN 1. There is no change for VLAN 1. For VLAN 1, both interfaces are having default cost. That is why 21 have been elected as a RP. For VLAN 5 also you will see that 21 will be RP because of they are having default cost, they are having common cost, and then finally election was done based on their designated port IDs. So now you can go for VLAN 6. For VLAN 6, of course, 22 must be configured as a root port. Must be, I mean, it have elected as a root port. Now you can see based on cost. Have you understood it now? So the traffic of all users which belongs to VLAN 1 to 5 will go through via 21, and the traffic of VLAN 6 to 10 will always go through via 22. So in this way you can get load balancing. Understood it or not?
Yes, sir.
Sure? Fine. Now this is that how can we manipulate your RP election based on cost. Next thing is interface fast Ethernet 1/0/22, and let's remove this command once again, and again you will come to know, I mean, switch 2 will elect 21 as RP for all VLANs. Fine. So spanning tree VLAN 1, of course 21 is going to be RP, and it will be, and for VLAN 10 also its RP will be 21.
Yes.
Is not it? Fine. Let's say that in task someone said that okay, this is 21 and this is 22, this is 21 and this is what, 22, and by default 21 at the end of stage 2 it is RP, and 22 is in blocking state. Now someone asks you that for VLAN 6 to 10 on stage 2, for VLAN 6 to 10 your RP must be 22, RP must be 22 for VLAN 6 to 10 only, but you are not allowed to do any modification on switch 2. So how can you manipulate now your RP election? By modifying designated port ID. By modifying designated port ID, because if you are not allowed to modify cost, however, first of all cost will be compared right before designated port ID. Remember, first of all cost will be compared before designated port ID. Fine, but this time this time cost is common, so definitely your RP election is done based on designated port ID this time, because designated bridge ID is also common. So here designated bridge ID is not taking place, and also we cannot manipulate this RP election based on designated bridge ID. However, I will let you know that in which conditions you can also modify your RP election based on designated bridge ID as well. But this time in this scenario it is not possible to manipulate your RP election based on designated bridge ID. So this time we are going to manipulate this RP election based on designated port ID. But remember that designated port ID can be modified only on designated bridge, only on upstream bridge. I mean, who is transmitting BPDUs? So of course you will be modifying, I mean you will do modification at the end of switch 1 only. So let's move on switch 1 now, and you know very well that all of them will be DP for all VLANs. So spanning tree VLAN 1, for VLAN 1 all of them are DP, for VLAN 10 also all of them are DP, and by default port priority is what, 128, and this port I mean this is number, right, and this number is assigned by iOS actually. This is not your physical number, because physical number is what, 21, but here it have allocated as 23, so it doesn't matter, right? You just need to know about your number, and you cannot modify this number manually, right? You cannot modify this interface number manually. You can simply modify only and only port priority. So this time we are going to manipulate RP election based on designated port priority. However, it will be comparing designated port ID, but port ID contains two things: one, priority plus port number. So port number cannot be changed, same as like inside bridge ID we cannot change MAC address, right? But we can change bridge priority. In same manner, inside port ID you cannot change port number, but you can change port priority.
Why it does not reveal the real ones?
Actually 3750 series of switches are stackable switches, so it have to define its port numbers logically, because you can stack, you can configure stacking between multiple 3750 series of switches, so all of them will become now single switch. So how will it be possible? Because all of them will be having 1 by 0 by 21 and something like that.
So there will be 2 by 0 by 21.
That's why. Fine. So I hope that now you have understood all these concepts. Fine. So now I'm gonna to modify all these things. I'm gonna to manipulate RP election from the end of switch 1. However, RP is not electing on switch 1. RP will be elected at the end of switch 2. But from here, by modifying the configuration of switch 1, we can manipulate RP election on switch 2. So this time I'm on switch 1, and because for VLAN 6 to 10 I wanted to configure 22 as RP, so on 22 I can configure its priority lower than 21, or configure higher priority on 21 than 22. So you can do whatever you want. But finally, remember, lower port priority will be preferred. So interface fast Ethernet 1 by 0 by 22, and I will say spanning tree port priority. And again remember, port priority can be configured in the increment of 16 only, same as bridge priority. But now if you change its priority, port priority, in this manner, like for an example, you decided to configure it as 112, because before 128 it will be 112. Fine. But this time it will change it for all VLANs. And this time I want it, however, this command can be configured, right? But it will change it for all VLANs. But I wanted to change it only for VLAN 6 to 10. So I will say spanning tree VLAN 6 to 10, and then I'll say port priority and what? Now on switch 1 show spanning tree VLAN 1, because I didn't made any change for VLAN 1. I didn't made any change for VLAN 1. That's why you can't see any change here for VLAN 1, right? But if you see if you see output of VLAN 6, now you will come to know that okay, you have made some changes over here. Like on 22 you have configured your port priority as 112. But still here you can see both of them are working as DP. So real impact of this configuration would be on switch 2. So now you can see show spanning tree VLAN 1. For VLAN 1 there is no change. Still 21 will remain RP. But if you check it for VLAN 6, of course your RP must be configured 22. 22 must be configured as RP. You see, it have been elected now as RP. Have you understood it now? And you can see this output in this way as well. So spanning tree interface, or you can say VLAN. VLAN is like 6 interface fast Ethernet 1 by 0 by 21, and of course 21 detail, and then for 22 detail, you see designated port ID 128 dot, and here it is designated port ID is what? 112.24. So first of all it will compare its priority. So is having lower priority, of course 22, that is why 22 has been elected as a RP. Is there any problem? Sure. Hello. If you configure this command like show spanning tree VLAN 6 interface fast Ethernet 1 by 0 by 22, after, let's say that after switch 2 you are having switch 3. So whenever you will see here root path cost, this one, sorry, designated path cost, here it will show you 19. Because whenever switch 2 will send BPDUs towards switch 3, in those BPDUs cost to reach root bridge will be specified as 19. Hello?
Yeah. Yes.
Are you not getting my point?
Yes, sir.
Because whenever switch will transmit a BPDU towards downstream switch, it will add the cost to reach root bridge, right? It will always add the cost to reach root bridge. So for switch 2 its upstream switch is what? Switch 1. And for switch 2, switch 3 is going to be downstream switch. Now I'm stopping this topic now. Then I was also telling you that you can also manipulate your RP election based on designated bridge ID as well. Let me show you. how can you achieve it? Let's say this is switch 1, this is switch 2, this is switch 3, and this is what? Switch 4. Now let's assume its bridge priority is 0. It's 32768. It is also what? And it is also, so root bridge selection will be based on bridge priority, and of course which one is going to be elect as root bridge. So both of them will be DP. Here it is going to be RP. Here it is also going to be RP, and here it will be DP, and here it will be DP. Now it will be depending on R4 that which interface is going to be RP, because if it is RP then definitely it will be in. So first of all it will compare cost to reach root bridge, right? And I hope so that cost will be same, because if BPD is coming on switch 4 via switch 2 or via switch 3, cost will be same. So next thing will be designated bridge ID. So might be that its MAC address is B and its MAC address is what? C. So which one is having lower bridge ID? Switch 2. So of course it is going to be RP and it will move into blocking state. Now I wanted to configure this interface as RP, this one, this blocking port. So what can I do? I can configure its bridge priority as 28672, lower than switch 2. So now MAC, it will not compare its MAC address now, it will compare simply designated bridge priority. So of course this is going to be now RP and it will be in blocking state. So in this kind of diagram you can also manipulate your RP election by modifying your designated bridge ID as well. Have you understood it or not? But remember that for RP election the comparison will always be in a sequence. First of all it will compare cost, then designated bridge ID, and finally it will compare designated port ID. Fine. Any problem related to STP, RP election, root bridge election with using primary keyword, secondary keyword? Now let's talk about timers, STP timers. You can also modify your STP timers. Are you getting my point? So whatever you will configure on root bridge, all other switches will follow same timers, because timers are always part of configuration BPD, and that configuration BPD will be generated by root bridge only, and all other switches will simply relay those BPDUs coming from root bridge. Is not it? So whatever you will configure on root bridge, all other switches will accept those timers. So in STP it is not mandatory to move on all switches and to change their STP timers. Just move on root bridge and change it. Like you can move on root bridge here, like if you are on switch 1 you can say spanning tree and VLAN 1 to 10, hello time is like hello interval, by default it is 2 seconds, you can make it 1 second. Spanning tree VLAN 1 to 10, forward time is by default 15 seconds, you can make it 10 seconds. Then spanning tree VLAN 1 to 10, you can also change maxes is by default 20, but you can make it 10 seconds. Then after if you move on any other switch, like if first of all let's check it on switch 1 itself. So spanning tree VLAN 1, let me show you. Hello is maxes, forward delay. Then you can move on switch 2 and then you can also check it out. Root ID. So on root bridge hello interval is what? Maxes, forward delay, but its on timers are something like hello is 2, maxes is 20, and forward delay timer is what? 15. Fine. So you will be required to modify your timers only on root bridge. Next question to all of you. Let's say that you have changed your timers on root bridge and you configured some different timers on root bridge, right? So all other switches will accept those timers which you configured on root bridge, right? Automatically, dynamically. Now, what is the requirement of having these timers on these non-root bridges? Will there be any use of these non-root bridges now? What?
So if the voltage is equal and the DC is equal, so we will follow this.
Of course, for TCN it is not gonna to use either forward delay or maxis timer, right? But the thing is, like for TCN, of course, hello time will be in use. Let's say that this switch have generated an TCN, but it didn't get TCN ACK back. So if it does not get TCN acknowledgement back from the upstream bridge, in that case it will retransmit that TCN BPD after 2 seconds only. So this will be uses of this hello interval here on this non-root bridge. Understood? Message edge is like whenever you are generating a message. So for how long it will be in your network?
Limit the size of the
What size of?
size of the
That is, I think, diameter. Yeah, I'm gonna tell you the diameter as well. So this is one way by which you can modify your STP timers. We are also having another method by which you can modify your STP timers. Like when you configure spanning tree VLAN 1 to 10, and when you say primary, root primary, and then after you can also define your diameter. And diameter can be configured in between 2 to 7, and by default your diameter is configured as 7. If you change your diameter, then your switch will configure its STP timers dynamically. It will change its timers accordingly, according to your diameter keyword. So by default your diameter is what? 7. So what is the meaning by this diameter 7?
Maybe we can connect 7.
It means that your BPDU will traverse 7 switches. It means BPDU will traverse 7 switches. Now you can ask me that, okay, in a huge switch network, how is it going to be possible? Remember that you will never connect your switches in a row. You will be having some layers like core, distribution and access. So of course you will configure either distribution layer switch or root core layer switch as a root bridge. So it will require to traverse only 2, 3 or maximum 4 switches only, not more than that.
Can we increase this?
No, you cannot increase your diameter from 7. This is the maximum, as you can see here, range.
message is same like a diameter.
What?
Message age.
Message edge.
Yeah. Like 14 seconds.
It's like the outcome thing.
Yeah, exactly.
PTL.
We are telling this switch that, okay, your BPDU, if you are generating a BPDU, it will traverse maximum this number of switches. So accordingly it will define its timers like hello interval, forward delay as well as maxes. So if you think that, okay, in your network your BPDU will traverse maximum 3 switches, then you can reduce your timers. But if you are thinking that, okay, your BPDU will require to traverse more and more switches, right? Then in that case, in those conditions, you must increase your STP timers for better performance of your switches. Because if you are having a huge number of switches in your switch network and then also you have reduced your STP timers, then of course it will affect your device performance, hardware performance. Fine? Any problem? Sure. So this is all about your timers. This is all about that how to manipulate RP election. Even I can also tell you that how to manipulate your DP election as well. But I think that I have already discussed it with you that how can we modify DP election between 2 non-root bridges. Of course, if you are having a root bridge, its all interfaces will be DP. There will not be any election, right? But in case if you are going to elect your DP in between 2 non-root bridges, then definitely there will be DP election and it will always start from coast. So in same manner, like we manipulated RP election, we can also manipulate DP election. Fine. All right. Even you are also having some Mac based ACLs. I'm not going to teach you all those things, but you can search about it and you can try to learn it by yourself. Like we are having some Mac based ACLs by which we can filter these BPDU messages as well. And if you filter BPDU messages, of course there will be a breathing loop. Even you can also disable instance of STP by saying, like for an example, this time you can see on switch 1 show spanning tree VLAN 5. So of course it is running STP instance for VLAN 5. But if you say no spanning tree VLAN 5, then definitely it will not run any instance of STP for VLAN 5. And now if you are having some users in VLAN 5 behind switch 1 as well as switch 2, there will be a breathing loop. And the lane users will never be able to communicate with each other if there is a breathing loop. Fine. So might be that breathing loop has occurred on your switch due to STP instance of STP. Might be that instance of STP for your VLAN is not running on your switch, and they can do it in your T-shoot. If you are going to attempt your CCA exam, might be that on your switch during T-shoot they will configure this command so that there will not be an instance running of STP for that VLAN. And if they are having some routers in that VLAN and they were having some OSPF peering or something like that, they will not form that peering. It's not it. Hey, try to understand. Like for an example, here you are having these two switches. These two switches are interconnected, switch 1 and switch 2. I'm using them as a layer 2 switch. 21 and 22 are there, right? And behind switch 1 you are having R1, behind switch 2 you are having R2, and you configure OSPF between them. So of course they will form OSPF peering, right? But in case if there is a breathing loop, will it be possible for these routers to form OSPF peering or EICRP peering? No. So they can do that. So be aware with that, right? Might be that they can configure this command like no spanning tree VLAN 5. So then after you will simply require to say spanning tree VLAN 5. So it will start to run instance of STP for VLAN 5. And one more thing, there are always limitations of maximum number of instances of STP per platform basis. Like here, these switches can support maximum 128 instances of STP at same time, but like 4500 and 6500 series of switches can support up to 4094 instances of STP at same time as well. So it will be depending on platform. Like here, if you configure like VLAN 1 to let me configure it 1 to 130. So it will give you an error message. See that this platform can create maximum 128 instances of STP or STP instances, right? So now if you run this command, so spanning tree VLAN 129, of course there will not be an instance of STP. And if you are having some users now behind switch 1 and switch 2 inside VLAN 129, definitely there will be a breathing loop. It does not mean that only for VLAN 1 to 128 only it will configure, it will run instance of STP. Don't think so. It means maximum number of instances can be 128 for any VLAN. Might be that you have configured your VTP mode as transparent on your bridge, so that you can also create some extended VLANs too. Is not it? Yeah. So this is total number of instances of STP. It doesn't mean that only for first 128 VLANs. No. Might be that you are not having VLAN 100 to 128 and then after you are having some other VLANs, so it will run instance of STP. Like for an example, right now it is not running STP instance for VLAN 129. Let's say, let me remove some VLANs from here. No VLAN 100 to 120, and this time you will see that it will configure, it will run instance of STP for VLAN 129 as well as VLAN 130. Let me show you. So spanning tree VLAN 129. Still I think it will take some time here. So spanning tree VLAN 100, of course it is not there, and now it must show me.
Got a message that we cannot create instance for 129.
No instance created. It didn't say it cannot.
Okay, it is not created.
Right? let me do one thing. Let me say no VLAN 129 and 130, and let's create them once again. Let's say VLAN 129 and VLAN 130, and now let me show you. Show spanning tree VLAN 129. My God. Show run pipe section include sorry. Oh, it configured this command actually. Show spanning tree VLAN 129.
Yeah.
Now VLAN 130 as well. Any problem? Sure. Let's talk about now STP protection. In STP protection, you are having various topics like root guard, loop guard, BPDU guard, BPDU filter, and finally UDLD. So these 5 features are available in STP protection. Root guard, loop guard, BPD filter, and finally UDLD. So I hope that most of the students are already aware with all these STP protection features, like what is the meaning by root guard, where to implement it, where do not implement it, because it is not always necessary or it is not always possible to configure this root guard everywhere, right? It's not possible. I'll let you know that what are the merits and demerits of configuring this root guard, and where can you implement this root guard and where can't you. And in same manner, loop guard is there. BPD guard, BPD filter will always be in use in production network. Without BPD guard and BPD filter, you cannot think about a production network, right? And finally, it is UDLD, unidirectional link detection. Let's start it from root guard. Why do we require to configure root guard in our switched network? Why is it necessary?
To prevent any new switch from coming in and becoming new switch.
Yes, it can happen actually. Let's say that you configure one of the switch as a root bridge in your switched network, and you configure this bridge priority as 0. Then after some time, you added a new older switch actually, right? And it was also having priority as by default, its bridge priority as 0. And then because decision would be done based on their MAC addresses, and of course older switch will always be having lower MAC address, so it will become root bridge. Fine. So once your root bridge will get changed, then definitely entire data flow will get changed. So to prevent your network from such kind of problems, you can enable root guard, right? You know very well that let's say that this is switch 1, and let's say this is switch 2, and this is what, switch 3, and if all of them are interconnected here, and let's say switch 1 is working as root bridge, so it will be DP, it will be RP, it will be RP, and it will be DP, and let's say it is in blocking state. So if there is any user behind switch 2 who have attached a switch with lower MAC address and lowest priority, so it will start to generate. Then switch 2 will receive superior BPD from here. So switch 2 will also transmit a copy of that BPD towards switch 1 and towards switch 3 as well. And if switch 1 receives this BPDU, however, it was not desired to receive BPD on DP because it was DP, and DP will always be responsible to transmit BPDU. So it is always not desirable to receive BPDUs on designated ports. And if you are receiving, if you have started to receive BPDU messages on designated ports, what does it mean? That someone else
Announcing itself as a root.
in our network is trying to become root bridge, or any other switch is also is having best bridge ID. Any other switch have become root bridge, is not it? If any other switch is not announcing itself as a root bridge, will it be really possible to receive BPDU on DP? Of course no, because DP will always be responsible to transmit BPDUs only. DP will never receive BPDUs. But if DP have started to receive BPDU, it means that any other switch have started to announce itself as a root bridge. So now what can we do to prevent our network from this kind of attacks? We can enable this root guard, but remember that root guard can be enabled only on DP. And as I said that it is never desirable to receive BPDU messages on designated ports, on DPs. It is never expected, is not it? So it is never expected to receive BPDU messages on DP, and if it is receiving, it means someone else is trying to become root bridge, right? So what can we do? We can enable this root guard on all DPs in the network, in the switched network, on all DP, but trunk port, DP trunk port, because by default your access ports will also be DP. By default access ports are also DP. So remember, you will enable this root guard only on DP trunk ports. And if you have enabled root guard on DP trunk ports, and then after if they receive any BPDU message, I mean in future if your DP designated port receives any BPDU message on that interface, in that case it will directly put that interface into root inconsistent state, but for that specific VLAN only. For that specific VLAN only, not for all VLAN. That's the difference in between inconsistent state and the error disabled state. Because if your switch port moves into error disabled state, it means it will move. I mean, it will be shut down for all VLANs.
Yes.
It will be down for all VLANs. But if we talk about inconsistent state, first of all, your interface will move into inconsistent state for specific VLANs only. Second thing, once your problem will get resolved, then your switch port will move from inconsistent state into normal state dynamically. Have you understood the differences between inconsistent state and error disabled state? If your switch port moves into error disabled state, it means it will be shut down for all VLANs. Right? I'm not talking about the error disabled recovery, right? You can also configure error disabled recovery on your switch, but let's assume that there is no error disabled recovery on your switch. So of course it will be down for all VLANs, right? And in case of inconsistent state, of course your switch port will move into inconsistent state for a specific VLAN only. Like for an example, this switch, this newly added switch, let's say that this user have started to generate BPDU messages, right, for a specific VLAN 10. So this PC have become now root bridge for VLAN 10 only. It means switch 1 will receive BPDU here on its DP for VLAN 10 only, and switch 3, this switch 3 will also receive BPDU on its DP for VLAN 10 only. So because on DPs we have already enabled root guard, so due to root guard, now switch 1 and switch 3, both switches will put their DP designated ports into root inconsistent state for VLAN 10 only. So now users behind switch 2 in VLAN 10 and the users behind switch 1 and switch 2 in switch 1 and switch 3, this is switch 3, right, in VLAN 10 cannot communicate with each other because switch 3 have put this DP into root inconsistent state, and ultimately the meaning by inconsistent state is like block. It will never allow traffic for that VLAN for which it have moved into inconsistent state. In same manner, switch 1 will also not allow traffic of VLAN 10 through this DP now. So what does it mean? That the LAN users of switch 2 in VLAN 10 will not be able to communicate with the LAN users behind switch 1 and switch 3 in VLAN 10 itself. So there will be some problems, of course there will be, but at least you can prevent your root bridge from attackers. Your root bridge will remain as root bridge. Like for switch 1 and switch 2, Still switch 1 will remain root breeze, but for switch 2 at least this attacker will become root breeze, because there was no DP available on switch 2. Was there? To prevent your network from these kind of attacks here on access ports, what can you do? You can enable either BPDU guard or BPDU filter. That is why it is always mandatory to enable BPDU guard or BPDU filter on all access ports. But what if that accidentally you made some changes in the breeze priority of any other switch? So it will become root breeze. So for that purpose, to prevent your network, your switch network, to prevent your root breeze from accidental changes, you can enable root guard in your switched network. So remember that after enabling root guard on any interface, if it receives any BPDU for any VLAN on that interface, then it will directly put that interface into root inconsistent state for that specific VLAN only for which it received BPDU message. Now this is again kind of problem as well. It can also cause a problem. How? Might be you are performing load balancing in your network, and a single interface can be DP for some of the VLANs and also can be root port for some of the VLANs. I mean non-DP, is not it? A single switch port can be DP for some VLANs and can also be non-DP for other VLANs due to PVST plus. Are you getting my point? So in that kind of environment, you will never enable root guard. So before going to enable root guard on any interface, make sure that your switch port is DP for all VLANs. Is not working as non-DP for any single VLAN. Because if it is working as non-DP for any other VLAN, any single VLAN, then again it will put that switch port into inconsistent state for that specific VLAN for which it was in non-DP state. And one more thing, the disadvantage of enabling this root guard is that because you cannot enable this root guard per VLAN. You will enable this root guard on DP under interface globe, I mean for all VLANs actually. You cannot specify that root guard is enabled only for these VLANs only. No, it's not possible. Have you understood it or not? Is it not possible to have, I mean, a switch port which is working as DP for some of the VLANs and also working as non-DP for some of the VLANs? Yeah, of course it is possible. Like for an example, this is switch 1 and this is what? Switch 2. This is for VLAN 1 to 5, it is root breeze. For VLAN 6 to 10, it is root breeze. So what will happen? For VLAN 1 to 5, it will be DP. For VLAN 1 to 5, it will be RP. For VLAN 6 to 10, it will be DP. For 6 to 10, it will be RP. Is not it? So before going to enable this root guard feature, you must ensure that your switch port is DP for all VLANs or not. If it is not DP for all VLANs, then you will never enable root guard on that interface. So I hope that now you have understood all these limitations now. Fine. Okay. That's all about the root guard. Let's talk about loop guard now. Loop guard. See, even after enabling STP in your switched network, STP is running, but still there are some conditions in which loop can form in your switched network, in your breezed domain. Fine. Let me tell you in which conditions loop can occur, right? And how can it occur? Let's say this is switch 1. This is switch 2. Its MAC address is A, its MAC address is B, 0 by 1, and this is what? 0 by 2. This is 0 by 1, 0 by 2. So it will be DP and will be in forwarding state, DP in forwarding state, right? And let's say it is RP and it is in blocking state. So there will not be any problem. There will not be any breezing loop. Now, accidentally switch 2 have stopped to receive BPDUs on its RP. Port is still up. Port is up. The status of interface is up. Line protocol is up. But switch 2 have stopped to receive BPDUs on its RP due to any reason, and it can be any reason, might be
Traffic
you can
congestion.
yeah, whatever it is, right? Might be that you are using fiber optical port, right? And in fiber optical port it is possible. I will let you know I will let you know later on that how is it possible, right? But this time you can assume here that, let's say that interface is up, there is no problem with physical interface, with physical connectivity, it is still up, line protocol is up, and except BPDUs all other type of traffic is also coming through this interface, right? But BPDUs are not coming. Now it will wait for 20 seconds only, which is max's timer, is not it? Because it received superior BPD on this interface. So as I said that by default max's timer for superior BPD is what? 20 seconds. So it will wait for 20 seconds, and after 20 seconds it will put this interface into listening state as RP, and finally it will move into
Forwarding.
and because on a single switch there cannot be more than one RP, right? So of course, because it have stopped to receive BPD here, so it will become now DP. Because it have stopped to receive BPDU, so it will start to transmit BPDU up from this interface now. Try to understand. If your switch is not receiving BPDU on any interface, then it will definitely transmit BPDUs out from that interface, and it will become DP. Now in this segment, like in between switch 1 and switch 2, this 0 by both ends have become DP,
Forwarding.
and it will move into forwarding state now finally, right? And it is DP, will move into forwarding state, it is RP, also will move into forwarding state. Now there is a loop. So as I said that in a single segment, if both ends are DP or non-DP, it means there is a bridging loop. There is a problem in your network. It should not happen anytime in your network that both ends have been configured as DP, but this time it is happening. It means there is a bridging loop. So how will you prevent now your switch network from bridging loops?
We enable the loop code.
By enabling loop guard. From these type of failures, to prevent your switch network from these type of failures, you can enable loop guard. See, as I said earlier on, that it is always mandatory that DP must receive BPDU messages. DP must always receive BPDU messages in every, sorry, DP must transmit, sorry, DP must transmit BPDU messages in every 2 seconds, whereas non-DP, whether it is alternate port or RP root port, must receive BPDU messages in every 2 seconds. So it is always mandatory on non-DP to receive BPDUs in every 2 seconds. If it does not receive BPDU messages, it means there is a problem. So what can we do? We can enable loop guard. Loop guard is simply reverse of root guard actually. So you will enable loop guard only on non-DP, only on non-DP interfaces. Non-DP means whether it is alternate port or RP. After enabling loop guard, remember, because it is always necessary to receive BPD interfaces on all non-DP interfaces, right? So after enabling loop guard, if your non-DP, whether it is alternate or RP root port, stops to receive BPDU messages coming from root bridge, then it will put that interface into loop inconsistent state. Loop inconsistent state, because non-DP must always keep on to receive BPDU messages, and if it is not receiving BPDU messages, it means there is a change, there is a problem actually in your network, right? So if non-DP, non-designated port stops to receive BPDU, then loop guard after 20 seconds, right? Because max's interval is what? 20 seconds. So if now let's say that again they are in their default states, of course this will be RP and it will be in blocking state. Now let's say that you have enabled loop guard on both interfaces. After enabling loop guard, now this RP have stopped to receive BPDUs, so it will wait for 20 seconds. After 20 seconds, loop guard will put it into loop inconsistent state, and if this 0 by 2 becomes RP and moves into forwarding state, will there be any loop now?
No.
Because this interface has already moved into loop inconsistent state, so there will not be any loop formation, bridging loop formation. So I hope that now you have understood it, right? Have you? Fine. So this is all about loop guard. So remember, loop guard will be enabled only on non-DP. And again, once you enable loop guard on any interface, it will get enabled for all VLANs. You cannot enable it for a specific VLAN. It will enable on that interface for all VLANs. So this is the uses of loop guard. So loop guard, the first condition, loop guard will get enabled. Loop guard should be enabled only on non-DPs. Second condition, after enabling loop guard, if your non-DP stops to receive BPDU messages, then it will put that interface into loop inconsistent state. Fine. Next thing is like BPDU guard and BPDU filter. So what do you mean by BPDU guard and BPDU filter? Is it really necessary for me to explain it to you? Don't you understand the differences between BPDU guard and BPDU filter? Guard, first thing that these features will be enabled only on access ports, not on trunk ports, right? You will never enable BPDU guard and BPDU filter on your trunk ports. You will always enable them only on access ports. Second thing, BPDU guard works into aggressive mode, whereas filter works in normal mode. Why I called this BPDU guard as aggressive mode? Like I said, that BPDU guard will work in aggressive mode. You know why? Because if you have enabled BPDU guard on access ports, then after, if you receive any single BPDU on that access port, because it is never expected to receive BPDU on an access port, because via access ports, of course, you will be having end users, right? End users connected, right? So via access ports, your end hosts will be connected, such as laptops, desktops. So of course, they will never generate BPDU. However, if any attacker is trying to generate BPDU messages with the help of any utility, then they can generate, right? Then your PCs, your laptop can also generate BPDU message. Fine. So now, because we cannot, we are not expecting any BPDU on any access interface, any access port. So we can enable this BPDU guard feature on all access ports, and then after enabling BPDU guard feature on all access ports, if it receives any single BPDU, then it will put, STP will put that interface into error disabled state immediately, right? But remember that, let's say that this is switch 1 and this is host, this is 0 by 1. If you have enabled BPDU guard here, in case of BPDU guard, it will keep on to transmit BPDUs out from this interface. Remember these differences. It will not stop all those BPDUs which are going out from, which are transmitted out from this interface. It will not stop them. But and one more thing. It does not mean that BPDUs from all VLANs will go out from this interface. No, because it will be member of a single VLAN. So the BPDUs of that VLAN only, which is configured on this access port, will be allowed to transmit out from this interface. But in case if it receives any BPDU here, just after receiving very first BPDU, it will directly put this interface into error disabled state. Then after, let's talk about BPDU filter as well. If you have enabled BPDU filter, very first thing, it will never let your switch to transmit BPDUs out from this interface. Very first thing, it will never let your switch to transmit BPDUs out from that interface where you have enabled BPDU filter. Second thing, if it receives any BPDU on this interface where you have enabled BPDU filter, it will discard those BPDUs. It will not process them, but will not put your interface into into error disabled state, unlike BPDU guard. Understood the difference between BPDU guard and BPDU filter? So which one is more secure, BPDU guard or filter? How BPDU filter is more secure than BPDU guard?
What is like our communication will be lost in BPDU guard, something like that.
BPDU filter prevent sendings.
Exactly. Because by enabling BPDU filter, even it will also stop to transmit BPDU messages out from our interface, right?
Yes.
Out from switch port, so that if any other user adds a switch on access port, then it will never be able, it will never be possible for that switch to receive BPDU from my side, right? And if that switch do not receive any BPDU from my side, it means my information will never be populated towards that switch, is not it? So of course BPDU filter is more secure than BPDU guard. However, BPDU guard works into aggressive mode. That's why if it receives any BPDU message, it will immediately put that interface into error disabled state. Any problem now?
The error disabled state also we can set a timer.
What?
Recovery.
Error disabled recovery? Yeah, of course you can configure it.
BPDU guard is better than
What?
BPDU guard is better than BPDU filter.
How?
If there is any error disabled state, then a person so and so second in the error disabled state and after
But at least your information can be populated towards your neighbor switch, is not it? Tell me. Your information will be populated towards your neighbor switch if you have enabled BPDU guard, is not it? But in case if you have enabled BPDU filter, your information will never be populated towards your neighbor switch. That's what I said. BPDU guard is taking action against receiving BPDUs only, whereas BPDU filter is working for both direction. Is not allowing incoming BPDUs and also is not allowing outgoing BPDUs. And if you have enabled both features on a single switch port, let's say BPDU guard as well as filter, which one would be preferred, guard or filter? Filter, right? BPDU filter will always be preferred over BPDU guard if you have enabled both of them. Fine. Next is what? UDLD. So I think today we do not have enough time to explain this UDLD now. Tomorrow we will continue from UDLD and then within 20 minutes we will implement all these things, right? And then after we will start RSTP. So please go through RSTP so that it will be easy for me to make you understand RSTP in tomorrow's class. And also you can ask some more questions.